everyone, welcome back to Armchair Technician. Today we're going to be taking a look at a 1978 Marshall JMP. This is the 100 watt master volume version of the JMP. We're going to be doing a full electrolytic recap job. But first, a little bit of history. The Marshall JMP, which stands for James Marshall Products, was produced from 1967 through 1980. There were numerous design changes during that period, especially in the mid-70s, like replacing the EL34 tubes with 6550s and switching production from point-to-point hand wiring to printed circuit boards. Another addition was the master volume that was added to the circuit to help tame the sheer loudness of the amps that they worked so hard to achieve in the mid-60s. Today we're looking at a nearly all-original model from 1978. Okay, so we've got this JMP opened up on the underside. So the capacitors that we're going to be replacing today are these four here. We've got one up here. And then unfortunately there's one under the board. And it's hiding out under here. So there's six total, at least six total of the can capacitors. And we're also going to replace these two. So we're going to have to do a little bit of work just to get this board removed, because as you can see, nothing is actually soldered from the top of the board. Everything is soldered from underneath, which is a pain in the ass. So we're gonna have to pretty much take this whole thing out in order to replace two components plus the can cap that's hidden underneath here. Great design work. So to get started, I'm just going to work on these four and this one up here by the fuse assemblies here, just because they're easily accessible. I can get a good start on this job without too much trouble. So for something like this, I always draw a diagram of everything, how it looks before I remove anything. Having a little sketch like this just makes it quicker and easier to make sure that you don't make any mistakes. Okay, and just to give me some room to work, I'm going to remove these two blue wires coming from the standby switch. So I'm marking which one goes to the terminal that's closer to the inside of the amp, so that's why I have the letter I stuck there. So, as you can see, this board is a pain in the ass to get underneath. That's the capacitor that I need to get to, but I have all this array of hookup wire that's, you know, hooked up to the pots inside here and so forth, and also to the tube sockets back here. And everything is soldered underneath. So it's a huge pain in the ass to get access to this board. But anyway, I'm sure you can understand the idea is to get underneath here with the slightest amount of modifications that you have to make in order to do so. So kind of figuring out my next move here. Okay, so I was able to get these leads undone from this can capacitor that's underneath the board. Now, how hard of a time I'm going to have hooking these back up to the new capacitor remains to be seen. We'll find that out later. But the real bitch is going to be accessing these two on the underside of the board, which I'll try to get a shot of this. It's almost impossible to see, but I have to solder points that are here, 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 and here. Somehow, without burning the insulation of all these wires that are going to and from. It's a huge pain in the ass. Okay, so I got out at least the positive ends, but I also forgot to mention that you have to be really careful when you're desoldering stuff from these. Basically, these are pressed circuit boards. Not to tear the copper leads that are run through the bottom side of this board, because if you tear those, then you're completely f***ed, and you have to start running jumpers, and you're like doing a bunch of cockamamie shit to fix the stuff that you broke while you're trying to repair this amp. So really the most important part of this whole process is your own level of patience, because if you get hasty, you get frustrated, you start applying a little too much force when you're trying to remove stuff from a board like this, you're just gonna f it up even worse, and it's gonna be embarrassing. I mean, seriously, it's like a game of operation in here. Now that we've gotten everything disconnected from the underside, we're gonna flip this thing over and disconnect the capacitor clamps from the top side. So all we're gonna do is loosen this little bolt right here to just let the tension off of the band that goes around the capacitor. We're going to leave these guys intact because we're going to reuse these clamps here. So now we're just going to do that 5 more times, and I'm not going to film the whole process. Of course, we have some problems with access, as usual with these designs, but on the bright side we have some good old standard measurements, good old 1/4 inch bolts here, because after all, this amp was made in England. Alright, so we've got all of these assholes removed. Here they are in all of their old glory. And here we have 6 of these replacement caps, these really sexy and expensive F&Ts. And just for a size comparison, this is one of the originals versus the replacement F&Ts. Alright, so we've got all these sexy new capacitors locked in the clamps. We're just gonna flip it over and start connecting everything, soldering everything back together. Alright, now I've pretty much done all I can do before I'm gonna have to take this board out, which is a huge pain in the ass. But there's really no way around it because I have to put 2 new caps in these spots here, and the only way to solder them in is to get underneath the board. So instead of having to desolder everything from the pots, I'm just going to actually physically remove the pots from the chassis. So I'm just going to take these off of the faceplate, loosen the nuts on the input jacks here, and then everything should just pull out, and I should be able to flip the board over on its, at least stand it upright so I can get underneath there. That'll save me a lot of time. Yeah, and also if you're ever doing this for yourself, these press circuit boards are very fragile because all these little tiny holes where the components go through, there's copper that's inside of this, little thin pieces of copper that, you know, take the signal and the power where it needs to go on the board. But it's very fragile, so if you're poking these through, You have to make sure they're lined up really straight before you push them through, because you can actually push this copper right out off the board. And that just, as you can probably imagine, it creates a whole other level of problems and difficulties for you. So just be very, very careful when you're putting component leads through a press circuit board. Alright, I've got these two caps dry mounted, and I've got the board sort of propped up with an ink pen. Yeah, whatever works. And this will be fine. I can solder these in and start putting everything back together. Alright, so I've got this can cap that was under the board. It's all soldered back up. Then I've got these two bad boys on top here. They're soldered in. So I'm going to start putting this back together. Kind of looks like a mess right now, but that's just the name of the game. Alright, everything's looking back to normal. Got these two guys on top of the board here, these new guys, and then everything, all the new can capacitors are where they're supposed to be. Everything's hooked back up. So what I'm going to do now is install the new tubes, and we're going to check the bias. Yeah, this amp has a adjustable bias pot. It's a fixed grid biased amp, but you can adjust the negative bias voltage here to make sure the tubes are not drawing too much or too little current. Alright, so I've got my trusty alligator clip here clipped onto pin 5 of the 6550 tube here. This is the grid of the 6550. We're looking for a negative voltage of negative 51 volts DC to correctly bias this tube in this particular circuit. So I've got my meter hooked up over here. Alright, we've got right at negative 51 volts. And we can actually adjust the bias pot here until we get the voltage that we want. So it's floating right around negative 51, and that's what we want to see. Alright, well that wraps her up for today. Thanks for watching, and tune in next time on Armchair Technician.